this work? Straight on there. Good morning, everybody. So first of all, I would like to clarify one thing. I'm not an academic. I'm not a doctor. Tony Ribbink was kind enough to shake my hand and congratulate me. Janine Osborne almost choked on her own spit laughing so hard. Thank you, Janine. However, if anybody out there's a lot of scientists and professors and academics out there, I would gladly accept an honorary PhD anytime. Just give me a call. So yes, my focus is more on the practical side, looking at the applications and trying to understand the realities of what these problems are that we have around us. So as part of that, the slide shows some of the things that I'm involved with, and I'm saying some of them. So yes, I'm a director of the African Circular Economy Network. We have 6,000 followers, 1,200 members, 140 country members in 34 African countries. We're driving that through the ASIN Foundation, and then we also have the practical applications through Sustainable Tech, Pyrolysis Group. We have the links with our companies in Brussels and Rotterdam, as well as companies in Mauritius, such as Green Waste X and Green Agri X. So the focus from my perspective really is to look at circular economy. Now I need to understand circular economy from my perspective is called economy. It's not called circular environment, it's not called circular social development, it's called circular economy. But the opportunity is that what that does is it brings us the opportunities and the applications to be able to say, how do we unpack the benefits and at the same time achieve the environmental and social goals that we need? So I'm going to whip through this because I think I've got about 3 minutes left before tea time. So thank you to everybody else for giving me the time. So I'll try and do it as quickly as I can. So we have a problem. We know that. In our developing economies, it doesn't matter whether you look at the trash island in the Maldives or if you look at Manila or in South Africa, just about around any corner, or even here, we have a problem. But we're not alone. So this works across the world. So if you look at the developed economies across the world, it doesn't matter whether you're in Hawaii or Norway. This stuff moves around. So we have a problem. We need to acknowledge that and understand it. But globally, what we're seeing is a whole bunch of different high-end products cashing in on the emotions around plastic waste. Now, this is good because it does raise awareness, but it really is addressing a tiny fraction of the global problem. So there's the ocean shoe, for example, which I'm not going to mention any brand names like Adidas, who are pushing the idea that they are saving the planet with 0.008% of their shoe production line using ocean plastics. And there are also other ones like the recovered ocean plastic sunglasses. Now, I'm pretty well off in terms of all these companies that I showed you, but I can't afford those things. I still go to Pep and Ackermans for my shoes. So yes, it's a nice idea. But there are good ones then. I've slipped that in about Cyclone. So any of you want to have a look at that, that really is a circular economy success story. So it can be done. And what they're doing is that they've designed materials, but then also from a circular economy perspective, they rent you the shoe. You use the shoe, you give it back to them, they recycle it, crunch it back up, put it back into a new shoe. That's circular economy. So the thinking is out there. Now, we have a clue where a lot of this waste is coming from. So we always look and point fingers. We point fingers at China, we point fingers at Southeast Asia, and we say, look how bad and naughty they are. But we're not doing so well ourselves. South Africa, again, how do you measure it? But apparently we're number 11 in the world in terms of plastic leakage into the ocean. So depending on who you speak to, that can be argued. But the reality is that even though we know where it's coming from, we don't need shoes and sunglasses. In Africa, we need sustainable solutions for the continent. We need to look at circular economy driving a just transition. And I'll go into some of that later. So there's a number of things that we can do. In recycling and upcycling, downcycling, whatever you want to call it, there's a number of different opportunities in terms of products that we can try and manufacture. Now, I try and focus on industrial products specifically because they target larger markets, and larger markets are going to absorb the volumes that you need. So we're continuously looking at new product development and trying to develop applications and outputs for this. So we've done plastic roof tiles, some of the stuff we've done in terms of different roof sheeting. We've used ABS, adenylene butadiene styrene, from electronic waste to produce gutter elbows and gutter components. There's piping and conduit systems, wood plastic composites. The new one that I'm looking at now is actually a Vietnamese technology which produces these plastic sheets from the problem plastics that we get from our river cleanups and our beach cleanups. And I've just got a container load that just arrived yesterday. And we're going to be testing the market in terms of the building industry from a permanent shutterboard, shutterproofing type system for the building industry. So the applications are there. And there's multiple of those. So if we look at the extrusion type processes and injection molding, there's a whole host of different applications. Those can go into furniture and social infrastructure. We should be replacing our palisade or our fence posts, our electricity posts, our sign posts with recycled material. And we can also then look at things like pavers, plastic boardwalks or wood plastic boardwalks, as well as plastic fencing. Plastic blocks, yep, I'm going to go into that a little bit just now. Certainly is an application, but it comes with its own problems. But there are multiple applications of this that we need to look at in terms of identifying and understanding the market. So how do we create a value out of the waste, and how do we look at converting that into something that then becomes a market value? And there's a number of things we're doing there. So plastic roads. I don't know who's heard of plastic roads. And there was this big hoo-ha recently about Jeffreys Bay. We're doing the first plastic road in the country. And they did this in conjunction with MacGregor, which is a Scottish company. What very few people understand is that because the Scottish company didn't understand the waste here, we actually imported the waste from Scotland to build that road. The reality is that we've been working on this for 5-7 years in this country. And there's groups called Shisalanga and Raubex who've been developing plastic roads for the 5 to 7 years. We've actually built roads long before that. And we're quietly testing them. And we quietly test things because as soon as you're putting a new product into the market, everybody jumps all over you. So you've got to make sure that you get the activity right. These are going to come into their fore. And what we've done is we've developed dry melt and hot melt systems where we're taking your sort of European type systems, which are taking maybe 7 to 12% plastic into the mix and using specific high value plastics, which is not what we want to do. We want to recycle those properly. We've converted them to systems where we're taking up to 45% mixed, contaminated, multi-laminate, unrecyclable plastics. And that's where the opportunity is, where we can now include up to about 60 tons of plastic per kilometer of single lane road. And it's cheaper, it's stronger, it's better, it's indestructible. We've actually just developed a pothole mix as well, which is actually amazing because you put this stuff into the potholes and the rest of the road collapses around the pothole now. So we know that these things work, but we've got to get them into the market. But also in terms of what we're looking at there are other opportunities in terms of looking at road infrastructure. So things like retaining blocks, paving stones, curb stones, drainage U-channels, you can see them all there. Those are all products that I've manufactured through the different groups that I work with and using 50% crushed glass with 50% unrecyclable plastics. And I keep saying unrecyclable because Doe Stain is here and he's going to throw things at me just now. Because we need to focus first and foremost on the recycling sector. So the waste hierarchy, we need to bring the highest value of that product back into the cycle. So don't worry, Doe, it's the stuff you can't use, okay? So if all these options are available, why are we not using them? And there's a number of reasons for that. First of all, we've just been using unsustainable for so long, we don't know how to change, or we don't want to change. We don't understand this new product. We don't know about it. And a lot of that really is about how we get those new products into the market. Understand that a lot of these other products have been around, some of them, for hundreds of years. So it's very difficult to change people's mindsets as to how we move this into a whole new dimension. But there are vested interests that are opposing us in terms of these market penetrations. Now, we're talking plastics here, but I work in multiple different applications. We're developing zero concrete or zero carbon cement alternatives from waste, etc. But the issue is that there's a lot of people out there who have vested interests. The cement industry, in terms of your paving stones, your curb stones, obviously are protecting their interest because they have had 300 years to develop a cement market. And they're very powerful, and I often feel that I have to drive around in a bulletproof car because I'm trying to destroy their market. With good reason, because the cement industry is about 8% of global emissions. And I believe that cement should be banned. And there are solutions around that. Anyway, so no guns, okay. But it's also issues around standards and certification. We have a very complicated market here, trying to get new products into the market. So there are issues around, I mentioned the plastic blocks. It's virtually impossible to get those into a house, virtually impossible, because you have multiple different certification standards. So you need to look at the off-spec standard, like an eco standard or an eco certification. You then need to look at Agrement certification, SABS standard certification. Then you need to go through National Home Building Regulation Council. Then you need to go through Construction Industry Development Board. Then you need to convince the architect. Then you need to convince the engineer. It's an absolute nightmare. But we need to have a holistic focus in terms of driving these things forward. The problem we have is that even we talk about state capture. I mean, even our standards and certification are captured by industry. Those with the vested interests, because all of our standards are based around a concrete standard. So when you put plastic into something, they go, what's that? It's not concrete. So there are opportunities we need to look at from that. And then how do we drive that from a green procurement, supply chain management, and material specification perspective? How do we make sure that that happens? And I'll touch on that on one of the next slides, which kind of gives you an indication as to the potential that this can bring forward. But there are a number of benefits to green public procurement that we need to address. I'm not going to go into the details of that. But consumer awareness is absolutely vital. How do we get people to understand that there are alternatives? There are more sustainable alternatives to what we're doing. There are solutions. So first and foremost, again, from a plastics perspective, we need to understand that there is a viable recycling market. It's not going to solve all of our problems, but we need to look at the waste hierarchy. We need to drive those high-value PETs, polypropylenes, polyethylenes back into the recycling market to offset virgin materials. We need to do that, and that definitely is an opportunity. But what do we do with the stuff that you can't do anything with? Even if you look at source separation programs, in the region of 30 to 40% of the plastics that are collected have little to no value. Now, there's a lot of good work that's happening through the likes of the pressure from Sustainable Seas Trust, through the SA Plastics Pact, to look at understanding how we redesign, how we look at eliminating those problematic fractions, or using more, or designing for recyclability. So there's opportunities there. But there are solutions and there are opportunities. The picture on the top right is one of my companies, Pyrolysis Group. We designed and developed a 1,200 liter per day pyrolysis unit, which was taking all of the problem plastics from one of our recycling areas. And we converted that into diesel. We ran all of our fleet of trucks off of that for 6 months, very successfully. And then the Environmental Affairs decided that they wanted to help me, which they did quite efficiently. So in terms of helping me, they said, listen, we need to understand that we've got to follow the rules, the regulations, but we're going to help you. So they issued me a Section 24G, which basically is 10 years in jail and 5 million rand fine. Now, this face is too pretty for jail. So we decided not to pull that thing through, and we've actually dismantled it and we've moved it aside. But we still have the opportunity to look at that. We're working with them. It's been years, but we have legislation and policy that doesn't make sense. We have a legislation, for example, that states any thermal treatment of any general waste, which includes plastic, of more than 10 kilograms per day, that then invokes the requirements of Section 8 of the Act, which requires you to do all sorts of strange sort of testing, of which we don't have the facilities in this country. So now you've got to do daily testing and sending air emission tests to the Netherlands at 80,000 rand a pop per day. It doesn't make sense. Anyway, so I'm going to get bitter and angry here, and I'm just going to move on from that. So if you look at the paving stones, and you see the little text on there, 8 million. 8 million equals 100,000 tons. Now, I want to contextualize that because we looked at, for example, the metros, and there's 8 metros. If you look at Durban, for example, Durban alone buys 1 million paving stones a year for replacement, for upgrades, for extensions. And if we took those products and we converted those into the crushed glass, plastic conversion systems, which are stronger, they last longer, and they're cheaper. That would soak up about 100,000 tons a year of our problem plastics. And it would create tens of thousands of jobs across the country. The pyrolysis unit we put together, we put together an analysis with the minister where we said, if we can distribute these at small scale, just drive these around into the different problem areas. Now you create a solution where every single person gets paid R2 a kilogram to pick up every piece of plastic that goes into producing a very crude fuel. Now you have a product that can be transported, because you don't want to transport plastic. That alone would create 117,000 jobs across the country and suck up 500,000 tons every year of problem plastics. Solutions are there. Implementation is a bit more difficult. And I said I'd come back to the blocks. The blocks are an issue. So we talk about certification and compliance. If you look at the compliance is based around the fact that we base all our standards on concrete. Now the test for a wall is that you have to put your blocks into a system, and then you have to subject it to 800 degrees open flames for 3.5 hours. What do you think that block's going to do? If you live in a house that's going to be subjected to 800 degrees for 3.5 hours, move. Don't figure it out. Anyway, so how do we look at the choices of technology? And there are a number of these different things. Sorry, I am rushing through it. I know everyone wants their tea. So looking at the choice of technology, there are a number of different things. There are great opportunities out there. We have pyrolysis, hydrolysis, thermolysis, gasification, dissolution. There are a whole host of different opportunities of technologies. Enzymolysis is another one that's come out. We keep changing, so the science is changing pretty well. But science needs to equate into reality, and that's often what we do, is that we then start looking at how do we put these systems into an African context that allows us to look at creating plug-and-play power options. And these are some of the ones, the plasma arc systems. There's the Scarab system. Scarab system is a locally produced, I think it's Cape Town and Joburg, and it's a small system. It works on 50 kilograms of plastic an hour, but it produces fuel. They're great systems, but they have applications and opportunities. But there are a lot of different types of modular applications, but these are also not just for plastics. They're for biomass, plastics, tires, mixed general waste. And they're modular from as small as I said, 600 kilograms per day up to about 30 tons per day. And the idea is that you can either produce energy or fuel as an output. Fuel is obviously energy, but fuel allows you to move that energy into a different application. But there are such amazing applications. We've developed one at 50 kilowatt output. My focus is, got 20 minutes. I can slow down. We've got a little system that produces 50 kilowatts. Now, put that into context. 50 kilowatts, if you look at your average middle-income home, uses about 1.2, 1.3 kilowatts per month. That would probably run about 30 middle-income homes. So the Back to the Future idea is there. It's still a passion of mine. I mean, remember Back to the Future? Some of you are too young. Where the car with the wing doors comes flying in there, and the guy steps out with these stupid glasses on and puts a banana peel and something into the top, and off they fly again into the future. We can do it. We can do it. I'm working on it. So 50 kilowatts is a small one, but I reckon that we do that at a household level. It is definitely possible. So we're working on scaling those sort of things. But then, more realistically, we're looking at sort of containerized units from 200 kilowatt output to 420 kilowatt output up to the big units at around about 30 megawatts. So these things are definitely adaptable. And again, multiple feedstocks. What are we doing with waste? Let's convert it into energy. And I'm going to try and explain why energy is important. But the fuels are critical in terms of understanding Africa. I mean, any of you, there's a lot of people from many different African countries here. One of the sounds we are very much used to is that general hum of generators. In South Africa, we're getting used to it too, pretty quickly. But the reality is that liquid fuels are a key component, whether it's an LNG, whether it's a liquid fuel or kerosene or a paraffin replacement. We need those fuels to run generators because we don't have that infrastructure. And the fuels that are produced out of these systems, they're what we call LSFO. It's a It's a low sulfur furnace oil. And it really is, it's geared for a shipping fuel or a generator or a boiler. I wouldn't put it into my Kia Sportage turbo diesel, but it certainly would work on that. But they're low sulfur fuels. They have a low flash point, low lubricity, and a high burnability of cetane or octane. But they're dirty. They're still a bit dirty. They contain gums, particulates, waxes, heavy oils. They're not suitable without further refining. But the further refining is a massive opportunity, again, because we import crude oil, and yet we're throwing away our own resources. There are better systems. Gasification can provide a much cleaner fuel. It's a little bit more expensive, but you're now producing that into a syngas, which now goes into a direct fuel replacement. So are they safe? Well, there's people who say no, and this is why I got the Section 24G. Cease and desist, because that's what people are used to. They're thinking about old technology. The one on the top left is an Indian tire pyrolysis unit we went to a number of years ago, and it's horrible stuff. I mean, it's just nasty, smoky, dirty, disgusting. And the one on the right, obviously, went wrong. So these things happen, and a lot of that happens because people don't understand technology, and they'll buy in technology. I mean, I can go out literally today. I can buy a 5-ton-per-day pyrolysis unit from China tomorrow, but it's made of boilerplate steel. I wouldn't put that in my microwave, let alone a pyrolysis unit. So literally what they're doing is they're selling bombs to the rest of the world. So good luck with that. But there are solutions. But you need to pay for what you get. And that unit that we built and developed is with 3CR12 steel that has a high thermal efficiency. It's all stainless. And that is the system operating, not a drop of smoke or gas. We had the minister up there who came in and said, Mr. Whyte, we want to see this operation running. I said, it is running. She says, it can't be running. There's no smoke, there's no noise. I'm going, no. Do you want smoke? I can give you smoke and noise. So you need to know the technology, the different applications and the opportunities that are out there. But plastic is energy. And that's what I'm trying to get across here, is that if you look at crude oil, and that little picture there shows it's nasty, black, smelly, high sulfur, full of heavy metals, dirty, gritty, disgusting, smelly stuff, okay? But we convert that, not all of it, but about 9% of it globally, we convert that into plastic. But understand and realize that energy, internal energy in terms of the crude oil is about 42 megajoules a kilogram. We convert that into plastic, but in doing so, we create 6 tons of carbon dioxide equivalents per ton of plastic that we develop to produce a clean product now, okay, which is around about 46 average megajoules per kilogram. Okay, so not much of an energy input, but man, that stuff's clean. There's no sulfur in it, there's no nasties, there's no dirties. We put it into a food grade type system, which allows us to develop those different opportunities and applications. Put that into perspective, coal is only, on average, 25 megajoules per kilogram. Okay, so it has a much higher energy content than coal. But then we landfill it, or we throw it away in the environment, even worse. And at landfill, it's estimated that creates about 3 tons per ton of plastic CO2 equivalents into the atmosphere. So we need to change that. We're taking energy, we're throwing away energy. Why are we throwing away energy? We need energy, especially if you're used to load shedding in South Africa. We definitely need energy. But industry is understanding that, and you're seeing already with post-COVID, you're seeing this global loss in demand, EVs as well. Yeah, the petroleum industry is going, nobody wants to buy our stuff anymore. So I hate to tell you this, but industry is spending about $400 billion in new plastic manufacturing facilities, okay, which is going to increase our plastic production, depending on who you speak to, between 25% and 40% over the next decade. It's not going away. We have to find solutions. We can convert it straight into electricity. This can be done through liquid fuels via boilers, gasifiers, but there's also incineration options, which is literally very simple stuff that goes into a fluidized bed that produces heat. Heat creates steam. Steam drives a turbine. I wouldn't justify plastic for that because obviously it's an open incineration, but that's very useful for biomass and other opportunities. or direct gasification through gas generators. But the opportunity is that energy can either be grid-tied or run off microgrids. Now, that's where it starts to get interesting. This presents huge opportunities for an energy transition in Africa. The biggest systems all require massive investment. We need high kilovolt lines, distribution, transformers, step up, step down, very lossy systems. You can imagine, very few people understand, taking power from Mpumalanga to Cape Town on a 765 kV line. You lose almost 30% of it by the time it gets to the other end. Okay, so it doesn't make sense at all. But then looking at that also comes with massive complications and power producer agreements and independent power producer contracts. Smaller is better. The opportunity is there. But let's put this into perspective. So Africa is energy poor. We have, at the moment, about 650 million people in Africa without access to electricity. 650 million. South Africa generates, this was 2019 figures, because Eskom's too embarrassed to put up the latest figures. We generated 209,000 gigawatt hours, okay, in 2019. In that same year, the entire production in Africa was 700,000 gigawatt hours. For a population of 1.4 billion, that population is going to increase by another billion people in 2050. A billion people. Somebody else was chatting about we have 60 million people pressure on our coastline, and in 2050 there's going to be 800 million people. It's the same sort of concept. So South Africa has 30% of Africa's generation capacity, but we only have 3% of China's generation capacity. New York, and not New York, New York, that's the little thing in the corner there, New York State, that goes right up to the Great Lakes, which is, put into perspective, 141,000 square kilometers. It's smaller than Eastern Cape, where you are now. Okay. They match half of Africa's capacity, just New York. Right. South Korea has 3 times our generation capacity, they're 12% our size, for a smaller population. So we need to put this into perspective. We need to recover energy on plastics and waste that we can't recycle. And I'm saying plastics and waste. Because energy is the basis of all secondary development in Africa. Without energy, we cannot develop secondary recycling. We cannot develop materials beneficiation, manufacturing, food processing, water management, wastewater management, communications, education, industry, social infrastructure, health. All of these, you need energy. We can't achieve the SDGs without energy. You can't. It's not possible. Energy has got to be a prime focus. So without energy, we can't achieve our SDGs. Okay, so now, first of all, I'll put this little note at the bottom. So don't panic. Plastics are not our only source being considered here. Okay, plastics are not the solution to everything. All right, so we're looking at all sorts of different things. We're looking at busy developing a global program now on a just transition to energy in Africa. And we're looking at everything from small-scale hydrogen development plants. We're looking at things like alternative water supply, ram pumps, which don't need electricity, but also no longer doing big dams, because big dams bugger up our biodiversity, our stream flow, and all the rest of it, and cause issues cross-boundary. You look at what's happening with the Nile at the moment. But we don't need to do that, because we have the technology with literally taking 1 to 2 meter head of water using microturbines to create energy at source without having to build dams, without having to go through all that infrastructure cost, which only governments and big corporates can afford, and then that just increases the gap between the haves and the have-nots. We need to look at all these things. A lot of my work at the moment is biomass in Africa, and there's some huge opportunities there, and in South Africa as well, but you've got to deal with Eskom. So we need to get all this before it gets into the sea. It's as simple as that. The opportunities are there. And there's some great stuff that's happening. So we have Our Blue Future we launched the other day. And part of that is that we're also driving solutions-based approaches using circular economy transition through our innovation teams. And there's opportunities around that. For those of you at the launch, or those of you not, please have a look at the follow Our Blue Future. And I think that there's some key opportunities around that. And I was also asked to mention also that the Regional Oceanal Governance Initiative, is driving the plastics agenda as well. We've got to look at focusing on the plastics and trying to find those solutions. Now, I think I've shown you some of those solutions. I'm hoping that I have. Obviously, I've rushed through this, but I think I've just made my time. 10 minutes? Oh, my goodness. Okay, you're going to get tea early. Okay. So the opportunity really is to understand that how we take this waste problem and convert that into a solution. It's there. We need to do that through partnerships. We need to do that through WIOMSA. We need to do that through the Regional Ocean Governance Initiative. We need to do it through WIOG. We need to do it through Our Blue Future. Those partnerships and SDG 17, Partnerships for Change, are the most vital component in terms of achieving those objectives. But stop seeing plastic as a problem and start looking at plastic as an opportunity. We have to create the value chains. And I think there's opportunities there where things like extended producer responsibility will play a role to create the value at the base of the pyramid, so we make sure that that stuff is collected. And we start gathering and collecting all these different bits and pieces and understand the value and the output component to that. So things like we're doing in Mauritius, for example, is understanding, they're saying coastal erosion is one of our biggest problems, but we're sitting with beaches full of plastic, and we have no glass recycling initiatives because we're too far from any market in Mauritius. And I and many other people drink a lot of alcohol in Mauritius. So how do you take that and convert that now into a retaining block that now becomes your coastal erosion protection? Creates jobs and creates value for the product. But then look at all those other different components. And the circular economy is very important. It's not just about plastics. So we are working on a number of different things. We're working with electronic waste. I'm doing a number of things with big corporates, particularly around chemical waste and understanding how to change that dynamic. But also regenerative agriculture, energy, water, education, infrastructure. These are all components that need to be part of the circular economy going forward. Plastics have a very big role to play in that. But we need to understand and appreciate the value of plastics. So I'm going to get shot down. I know Doe loves me to pieces because I keep saying plastics are lacquer. But they are. We need to understand and embrace the opportunity that's there. So rather than seeing it as a problem, let's look at it as an opportunity and try and move forward to solutions that are going to bring those just transitions and those economic opportunities to Africa. So the solutions are not only possible, they're economically viable. We need to wake up, we need to pay attention to those, and we need to grasp those opportunities and collaborate and work and build up the science behind it, which is what you're all here for. And understand that all of this is part of the way forward. We talked about the MPAs, Prof. Those are vitally important, but they're full of plastic. How do we look at the opportunities around that and bring all these different components together and make sure that it happens? So thank you very much for your attention. Enjoy your tea.